Hello everyone, welcome to the class once again. After learning the chapter laws of motion, let's practice some questions based upon JEE Advanced pattern. In JEE Advanced, questions are asked based upon single choice question. You can get more than one choice correct. You can get integer type and you can even get matrix match and assertion reason. Let's go ahead with the pattern of questions that we are having today, that is actually based upon JEE Advanced pattern. Let's go ahead with the first question of the day, that is the first one. You can see the question statement and the diagram given here. With what acceleration a should the box of figure descend so that the block of mass capital M exerts a force mg by 4 on the floor of the box? So we have a diagram given here. It's provided that with what acceleration, we have to find out the acceleration with which this box should actually move downwards, so that the mass M, block of mass M, exerts a force mg by 4 on the floor of the box. So if I go ahead and if I mark the force that is actually acting as mg by 4 on the floor of the box, this is actually exerting a force mg by 4 on the floor, that is mass M exerts a force mg by 4. Now we all know that the normal reaction will be this, it will be acting in the upward direction. Now see, on this block, first of all understand, as this is coming down, we all know that the force that will be acting due to earth, that will be acting mg downwards. So what I am going to do, I am going to make a free body diagram of this block M. So let us draw a free body diagram of block M. So we have this block M. It exerts a force given mg by 4 on the floor. Now try to understand, if it exerts mg by 4, the floor will also exert a force that will be equal to mg by 4. So if I write here n equals to mg by 4, this will be the value of normal reaction. Next force acting, that will be due to its own weight, earth will be attracting it downward with a force mg. Acceleration A, go ahead, solve the question, you can easily get the value of acceleration A. We know that along the vertical direction, if I write F net is equal to mass into acceleration, F net equals to mass into acceleration, so that will turn out to be, you see here, net force acting in the downward direction, that is capital mg, in the upward direction, that is mg by 4. So we can write mg minus mg by 4 is equal to ma. A we need to evaluate. If I cancel out m from every part, g minus g by 4, we will be having A equals to 3g by 4. Quite obvious. Let's check the answer. Let's check the answer. A equals to 3g by 4. That will turn out to be option number B. Option number A is g by 4 incorrect. Option number B, 3g by 4, that is the correct answer that we are having here. The next one, option number C, g by 2, again it's incorrect. D, g by 3, that is the incorrect response. So let's go ahead and let me rub the entire part so that we can solve for the next question. I believe that this is pretty much clear to you all how to solve such kind of question. That's also obvious, it's a very simple question, not too tough. Let's go ahead. Second one, a body of mass small m is suspended by two strings making angles alpha and beta with the horizontal. Find the tension in the string making angle alpha with the horizontal. So again, need not to worry about the diagram that I will be drawing for you all. How will it look like? See, it says that a body of mass m is suspended by two strings making angle alpha and beta with the horizontal. So see here, if I make how the body is hanging, this will be the ceiling, then we will be having two strings which will be actually connecting the body of mass small m. Now see here, it's given that the angle that they make, this is alpha, this is beta. See, this is what has been given. You check here, both the strings make an angle alpha and beta with the horizontal. So I made this string makes an angle alpha, this string makes an angle beta. Find the tension in the string making angle alpha with the horizontal. So we need to evaluate the tension that is in the string acting here. Tension is T. So let me show you that. Let's say this is tension T, and let me say that here the tension acting, that is T dash. in the next string that I have shown, that is the tension T dash acting in the other string and tension T is acting in this part of the string. So if I show you for the horizontal equilibrium, we will be having T cos alpha should be equal to T dash cos beta. So let us write T cos alpha for horizontal equilibrium of the block. For horizontal equilibrium, we will be having T cos alpha is equal to T1 cos beta, equation number 1. So we got here. We need to evaluate the value of this tension T. That is what is required. These 4 options have been provided to us. Let's go with the vertical equilibrium. You can easily see that T sin alpha plus T dash sin beta should be equal to the weight of the block, that is mg acting downwards. So let me show you here. The weight is acting mg downwards. So for vertical equilibrium, we need to write down the equation. For vertical equilibrium, we will be having T sin alpha plus T dash sin beta. This will turn out to be equal to mg. Equation number 2. 2 equations, 2 unknowns, easily we can find out the one of the unknown, that is T dash. So if we eliminate T dash here, see I have written here T1, just to change here I have written here T1, that is actually T dash. So it's T dash not T1 and here I have used T dash. Now you go ahead, T dash will be actually T cos alpha by cos beta. Substitute the value of T dash from this equation number 1. In this equation you will be having T sin alpha plus T dash, instead of T dash you can use T cos alpha divided by cos beta into sin beta is equal to mg. So we got this. Now easily you can see that you can make T as the subject. So if I make T as the subject, we can actually make the equation as shown here. If I make T as the subject and cos beta as the denominator, if I take a LCM, I will be having T sin alpha cos beta, T sin alpha cos beta plus cos alpha sin beta, cos alpha sin beta, and in the denominator we will be having that will be equal to cos beta. I am taking at the other end, it will turn out to be mg cos beta. So if we check sin alpha cos beta plus cos alpha sin beta, that is equal to sin alpha plus beta. So T turns out to be mg cos beta upon sin alpha plus beta. Mg cos beta upon sin alpha plus beta. Let's go ahead and check the options. Mg cos beta upon sin alpha plus beta, that is option number A is the right answer. B incorrect. Cos alpha we have here no trigonometrical function given. This is also incorrect, only option number A is the right answer. Let's go ahead with the next question, and before that let me just wipe the board for you all. This was a good question and you should have a practice of solving such kind of questions. Single choice question can be directly asked based upon such concepts. Let's go ahead with the next question. Third one, a uniform rope of length capital L and mass capital M lying on a smooth table is pulled by a constant force F. What is the tension in the rope at a distance L from the end where the force is applied? Option number A, Fl by capital L, B, 2Fl by capital L, C, F1 minus L by L, D, F2 minus L by L. Let's check, first of all, let me clear up the scenario, what is actually given and what is actually asked. Just imagine if this is the rope. I am showing the width of the rope. Let's say the ends are A and B. You are applying a force F at this end. From this end, at a distance L, we need to evaluate what is the, you see here, what is the tension in the rope at a distance small l from the end where the force is applied. The rope is being pulled. So at this end we need to find out the tension. If I show you here, if I mark a line and I write here tension acting is T, we need to evaluate this tension. Let us do a breakup of this rope. If we do a breakup of this rope, how will it look like? See, I am just breaking up this rope into two parts. One, from the end L, I have just broken up the rope, and let me call this end as C. This end that was C from the end L. So this is A, this is B, and here the tension are acting. When you are pulling, you see here, you see this force. As you pull this, tension will be created at every point. We are interested in finding the tension at this point. So let me show you the direction of tension that will be actually acting here. And since I have drawn a smaller diagram, let me draw a bit larger diagram. Now it's okay. Tension T will be acting here and tension T will be acting here. This is what the case will actually look like. A, this is point C for both the wires, and this is B. Now you see here, if we consider this part is being pulled by this tension T, and before that, for the entire rope, force F is acting. Its mass is given as capital M. For entire rope, the acceleration will come out to be F by capital M. And if I consider the part AC, it will be being pulled by this tension T. So for part AC, force is equal to mass into acceleration. We know that F net is equal to its own mass into acceleration. Now net force is actually tension T acting along the right hand side direction. Its mass will be total mass per unit length multiplied with length of the part AC, that is actually capital L minus a small l. So I am writing here capital L minus a small l multiplied with acceleration, that is actually F by capital M. You can see here M and M will be cancelled out. You will be obtaining F, and this will come out to be 1 minus L by capital L. This is the value of tension. This will be the answer for the tension that is actually acting at point C. This is point C that you can see here. So tension at this point will be given by F into 1 minus cap small l by capital L, and C is the right answer. Rest all the options are incorrect. Right option, you have to take the option number C to get the full marks for this. I hope that you would have understood how to solve this question. Let's move ahead. I hope that you would have already practiced more questions on laws of motion and you will finding it easy to solve such kind of question. Let's go ahead with the fourth one. Two identical ladders are arranged as shown in figure. So we have two identical ladders. Mass of each ladder is capital M. Each ladder has mass capital M and length capital L. They have the length capital L that has been provided. So I am writing here length is L and mass is capital M. So let me just clearly depict that the mass is given as capital M. Now let's go ahead. Mass of each ladder is capital M and length capital L. The system is in equilibrium. Find direction and magnitude of frictional force acting at A or B. So at A or B we need to find out the frictional force. Option number A, M plus M by 2 G cot theta. B, 3 by 2 M plus M G sec theta. It's actually small m. So just make it small m here, because 2m capital M will not be required, to be directly given as 3 capital M. Now C is M plus small m by 3 G tan theta. D is M plus small m by 2 G sin theta. Let's be very quick to solve this. You see here the case is one ladder, second ladder. You can see one ladder this point and second ladder is here. Mass, this small m is hanging here and it is in equilibrium. So if I draw only one of the ladder and if I try to make its free body diagram, how will it look like? One of the ladder I am drawing. This is the ladder that I am interested to show you all here. Now see, let's try to make out the forces. Now see, both ladders are at the verge of slipping. It's the friction force that is not allowing it to slip. Friction at point A will be acting towards right. It will not let it slip. So I am marking the friction force acting towards right, small f, and then let me show you that this is the normal reaction N. Now next thing, you see at point P, this mass has been hanged. So I can clearly, since it is connected to both of the ladders, so its half weight will be actually acting on this. So I am writing here the force acting is mg by 2, its own weight capital Mg will be acting here. Now let's talk about the normal reaction due to the other ladder. Both ladders are in this way. You can just, I will show you a diagram. These are the chalk holders, both ladders are this way. This ladder will be exerting a force normal reaction on this along this left hand side right hand side direction, and this ladder will be exerting a force along the normal along left hand side direction. So for this ladder, the normal reaction that will be acting, that will be towards this end, as I am going to show you all here. Let me call this as N1. Pretty much clear to you all, I believe, that how you can actually show you all the forces. Now for this, and let us take this point as O. It's given as P, so I will take it as P, not a problem. I take it as P, this point A. And this is given as theta. Now for vertical equilibrium, you see here, if I talk about vertical equilibrium, Fy should be equal to 0, that is net force acting along vertical direction is 0. Mg by 2 acting downwards, capital Mg acting downwards, N is acting upwards. So we can easily write that N is equal to Mg plus Mg by 2, not a problem. N equals to Mg plus Mg by 2. Let's go ahead. Now you see here, next you can write here friction force F, that will be equal to N1. Quite simple, we can easily write that friction force F will be equal to N1. This is what we can easily depict. Next you see for the vertical, for the horizontal, I have not written that sigma Fx should be equal to 0, and from here I believe that you all can clearly see up to this end. So we can write that F, that is the friction force, should be equal to N1. F here, N1 here, so we can write it. Now after all this, let's see the rotational equilibrium. The net torque acting about this point P should be 0. So torque acting about point P should be 0. I am using this point torque. If you are not aware of this, take this as the moment of force. Torque is actually moment of force. If you are not aware, I have told you about the equilibrium, that moment of all the forces should be 0. So about this point P, we are talking about moment of forces. Now see, N is acting here. If I talk about its moment, that will come out to be N, and you see here this distance will be L cos theta. So NL cos theta, and its effect, if you try to see its effect, I have to do R cross F, its effect and its direction will be going into the plane of the board. Next see this Mg and Mg by 2, they are acting along the downward direction. Mg by 2 will have got no role to play. Mg, you see this length will be L by 2. This length will be L by 2. Mg torque effect, its moment of force, that will be L by 2 cos theta. So I am going to write Mg, L, its distance from this point, it will be L by 2 cos theta. Let's try to see its effect. It is coming out of the plane of the board, its direction out of the plane of the board. If you take R cross F out of the plane of the board, so I have to mention Mg L by 2 cos theta. So I am mentioning here, this will be equal to Mg L by 2, and again you see this length. This length will be L by 2 cos theta. So I have to mention L by 2 cos theta. Next point, try to see. N we referred to Mg also. Now see F will be also providing a torque. F torque should be equal to F into L sin theta, because we have to see this distance, this will be L sin theta. Next its effect will be also out of the plane of the board. So L sin theta I have to multiply, so this will be FL sin theta, so I have to mention plus, and let me write here FL sin theta. Pretty much clear to you all, I believe, that FL sin theta how we have made. So we have used F, we have used N, we have used Mg, it has got no torque, it has got no role to play. F we got as a subject, let me mark this is equation number 2 or 3, it will be better, 3 equations we have, equation number 3, and then we have equation number 1, equation number 1 we have here, equation number 2 we have here. Capital N can be replaced as mg plus mg by 2. So that is what I am going to do. I am going to replace capital N by mg plus mg by 2. So let me write here mg plus small mg by 2, and this is multiplied with L cos theta is equal to, now see mg L by 2 cos theta, so is equal to mg L by 2 cos theta plus FL sin theta. All terms are given, F is the unknown, or easily we can evaluate. See, L is here, L is here, L is here, we can cancel out the value of L, that won't be required. So what I'm going to do, I'm going to just cancel out L from here, from here, from here. Now see mg cos theta, and here I have mg by 2 cos theta. If it goes there, I'll be having mg by 2 cos theta. So just you calculate, you just rub your pen on your copy, and you will find that this term can be written as mg by 2 cos theta plus mg by 2 cos theta is equal to f sin theta. So we got this mg by 2 cos theta plus mg by 2 cos theta is equal to f sin theta. Now g cos theta can be taken as common, and if we divide with sin theta, we will be having g cot theta. So final answer, I believe that you would have taken down the diagram. I am rubbing this part. The final answer that turns out to be for the value of frictional force that we need to evaluate, that will come out to be F is equal to, let me take g cot theta as common, and it will be m plus small m by 2 multiplied with g cot theta. This will be the answer. Let's check the answer. M plus m by 2 g cot theta, that is the first answer, first option is the real answer, that is the actual answer. Rest all the options are incorrect. Let's proceed with the next one. I hope that it is quite clear to you all how to solve such questions. It was a good question. And all the questions that we are discussing, some of the questions have been asked in previous year examination. So you should be very attentive to learn how these questions are solved. Next question, question number 5. A block of mass small m rests on a horizontal floor with which it has a coefficient of static friction mu. It is desired to make the body move by applying the minimum possible force capital F. Find the magnitude of F which has to be applied. Now before I solve this question, I want you all to draw the diagram, and you just try it on your own, and then I'll be proceeding with the actual answer. This is the body with mass capital M. The coefficient of friction between both the block and the floor is given as mu. It is required to pull it with the minimum force. Now see, the maximum friction force that can act on this block, that will be actually acting, now see mg will be acting here, n will be acting here, that will be equal to mg, not mg, I will not use mg this term, we will use it later on. Now next you see here, the maximum friction force that can act on this block, that will be given as mu into n. The maximum friction force that will be acting on this block, that will be given as F max is equal to mu into n. Now how the block will be pulled? If the block force is applied along this direction, the angle that they are referring to in the question, that is, this is the theta that they are referring to. What is the minimum value of this force that we need to apply? Check here, this is normal reaction. I am not making normal reaction as equal to mg, that we did incorrect. First of all, write normal reaction. For vertical equilibrium, body is not moving vertically. For vertical equilibrium, n plus f sin theta should be equal to mg. So write here n plus f sin theta is equal to mg. Since we want to use the minimum force, so if I talk about limiting case, for horizontal movement, f cos theta should be equal to mu into n, that is equal to frictional force. So I am writing here, first I will write frictional force. See, because we are referring to limiting case, so that's why I am referring to f max. So f cos theta should be equal to mu into n. This is the term that we need to refer in this one, in this question. So what to do? We have to do further more things. So take note till here. I'll start at the other end. Take note till here. I believe that you would have taken note of this equations. I believe that you would have understood how it has been obtained. Now next thing you see, we need to find out the minimum force. For minimum force, we need to understand that we need the maximum and minimum equation. So let's go ahead. First of all, I will try to find out the value of f and how it's related with theta. You see here, if I replace n by f cos theta by mu here, we will be having f cos theta by mu. See how we are doing this. Equation number 1, equation number 2, we are substituting the value of n from 2 in equation number 1. F cos theta by mu plus f sin theta, that will be equal to capital Mg. Now easily we can find out f will be equal to mu mg divided by cos theta plus mu sin theta. Obtained. So we obtained the value of f. This is the f, but still we are not aware whether this minimum or what is the value of f. Now see, for minimum the denominator has to be maximum. So if I take cos theta plus mu sin theta and we need to maximize it, let me rub this part. This is useful. So if we go ahead, if we use cos theta plus mu sin theta, if I take it as a term, let's say it is x is equal to cos theta plus mu sin theta, I need to maximize it, and for it we will be having dx by d theta. This should be equal to, this will be minus sin theta plus mu cos theta. Now equate it to 0. So you need to write dx by d theta is equal to 0. Easily you can see that mu will come out to be sin theta by cos theta, that will be equal to tan theta. You will be seeing mu is equal to tan theta. So if you put here mu equals to tan theta, you can easily obtain the value of f, that would be the f minimum. So for maximum value of the denominator we obtained. So for f minimum, you see here, for f minimum put mu equals to tan theta. Mu is equal to tan theta. Now if we put this, so we will be having sin theta by cos theta is equal to mu. Put here tan theta and rest of the terms are given. You will be obtaining that f minimum will come out to be mg sin theta. This will come out to be mg sin theta. So let's go ahead and see the option. If we have put out this, it says small m used, I have used somewhere capital M. Refer it to be small m everywhere. So option number A will be the right answer, that is mg sin theta. This is how the method that you have to use to find out the minimum value of force that we need to apply. Let's go ahead. After this one, this was a good question. I hope that you have understood how to solve such kind of questions. The next one that we have, the next question of the class, question number 6. Now we have integer type question. If the tension T in the string is x into 10 Newton, tension T in the string x into 10 Newton, the value of x is, easy question, need not to worry about it. You see here, first of all, let's talk about the equilibrium. It's given 30 degree here. So if I show you the block, it's free body diagram. One of the strings is acting here. One of the string tension is acting here. Let me call this as T1. Let me call this as T2. It's given at T. We need to find out only T. So I'm using only T here. Now see here, it's given that this angle is 30 degree. So I'm marking this angle is 30 degree. So obviously this angle will be also 30 degree. 4 kg weight. So 4 kg weight acting along the downward direction. T sin 30 degree will be acting along upward direction. Equate the forces along the vertical direction. We will be having T sin 30 degree is equal to 4 kg weight. So 4 into g, that is 10, 40. So T comes out to be 4 into 10, 40 divided by sin 30, that is equal to 1 by 2. That will come out to be 80 newtons. It's given that tension T is given as x into 10, that is equal to 8 into 10. So x will be equal to, you need to fill the dot, which is actually having x equal to 8. So your answer will be x equal to 8. This is the circle that you have to make in your OMR sheet for such kind of question. Let's go ahead with the next problem. Question number 7 that we have, again it's an integer type. A block of mass 200 kg is set into motion on a frictionless horizontal surface. A block of mass 200 kg, this is the block. With the help of a frictionless pulley and a rope system as shown, you can see the system. What horizontal force F should be applied to produce in the block an acceleration of 1 meter per square second? So we need to apply a force here, an acceleration of 1 meter per square second. Give your answer in multiple of 10. Integer type, such questions, even such thing can also be given, so that you get the answer as an integer. Now let's see here. First of all, let me write down, let me make the diagram. You are having a block, its weight, its mass is given as 200 kg. Pulley is attached. Now see, this is one of the string. Now see, string is same. Let me say that this is tension T acting here. Here force F is acting. Same string, so same tension T that will be developed, that will be equal to force F. This is moving with an acceleration of 1 meter per square second. Moving with an acceleration of 1 meter per square second, and that means the tension that is acting here, the tension T that I have made here, that will be equal to mass into acceleration, 200 into 1, that will be equal to 200 Newton. Now this 2F should be equal to T, pulley is light, so 2F should be equal to T, so F comes out to be T by 2, that is equal to 100 Newton. So 100 Newton, you have to give an answer in multiples of 10, that 10 will be the answer. So you need to circle 10, so your answer will be 10 here. Now obviously the question that is asked in JEE Advanced pattern, the integers are given as 0 to 9. So but here we have 10, if you get 0 to 9 in some other question answer, encircle the right bubble for 0 to 9. This was just an example to show you all that even such thing can also give your answer in multiple of 10. Let's go ahead with the next question. Let me clear the board for you all. The next question we have, question number 8. More than one choice. A block of mass small m is at rest on a rough wedge as shown in figure. What is the force exerted by the wedge on the block? Prior to that, I want to read it once again. A block of mass small m is at rest on a rough wedge as shown in figure. What is the force exerted by the wedge on the block? This is a wedge. I believe that you all cannot identify. I will draw the diagram. So what you do, I will draw the diagram of the wedge. It's shown in this way. This is M and this is angle, some angle given, and let me say that this angle theta, and we need to find out the rest of the things. What is the force exerted by the wedge on the block? A, vertically upward, where the force is acting vertically upward. B, mg sin theta. C, mg, D, parallel to incline. Multiple choice, more than one correct can be, even one correct, even two correct, three correct, all four correct. Let's see, all four correct is not a possibility based upon the options. See, first of all, you see, the block is in equilibrium. The block is in equilibrium. This block, its weight will be acting vertically downward. So what I'm going to show you, the weight is acting along the vertical downward direction. So let me show you here that mg is acting along the downward direction. It's in equilibrium. Quite simple for us to make out that the surface will be exerting net force. I'm writing net force that will be equal to mg. If you are thinking whether the surface is exerting normal reaction, that is mg cos theta, you may think that the normal reaction is mg cos theta. It's okay. I believe that you all can easily think that. What about the friction force? If that is not coming in your mind, it should strike your mind. The friction force is acting on it. that should be equal to mg sine theta. The resultant of these two will be the net force, that is mg, and it's acting on the vertically upward direction. This is the beauty of this question, that you need to see. It's a simple question. It may seem like as I solve it, but in the examination you may think that why not to give a normal reaction, that will be mg cos theta. That is where people get confused. Don't get confused. The answer is mg, not mg sine theta or mg cos theta. Mg, and it's acting vertically upward. So A and C are the right answer. So take note of this diagram, take note of the solution, and let me start for the next question. With the next question, okay, I believe that you would have taken on the diagram and you would have understood how to actually understand such kind of question. Even such kind of tricky questions can be asked in your JEE Advanced examination. Let's go ahead with the next one. Question number 9. Cricket ball of mass 150 gram is moving with a velocity of 12 meter per second and is hit by a bat so that the ball is turned back with a velocity of 20 meter per second. If the duration of contact between the ball and bat is 0.01 second, find the impulse exerted on the ball by the bat and the average force exerted. I believe that you must be remembering the concept of impulse. The ball was coming along this direction. This is the initial velocity that is given as 12 meter per second. It has been hit by bat as the bat strikes and again starts moving with the final velocity that is given as 20 meter per second. The change in momentum, we talk about change in momentum, delta P, that will be final momentum minus initial momentum. Let's take the left hand side direction as positive. So we'll be having 20, so see, mass into final velocity minus, and here also let me say it's a vector, so we need to use vector sign, minus initial velocity. Mass is 150 grams, so 0.15 kg. Change in velocity. 20 minus 12. Understand? 20 minus 12. So we will be having this with proper units. Kg meter per second. 20, that 32 into 0.15. That will give you 32 into 0.15. That will give you 4.8 kg meter per second. Just check the calculation. So first of all, let me talk about the impulse. That will be 4.8 kg meter per second, or it's Newton second. So 4.8 Newton second can also be taken as the answer. What is the average force exerted? Average force change in momentum per unit time. So we can say that will impulse per unit time. So F average impulse divided by time. So that will be actually equal to 4.8 divided by 0.01, that will come out to be 480 Newton. Let's check the answer. We can see option number C, that is having 480 Newton. That is the right answer for the average force exerted on the ball for this change in momentum. Let's go ahead with the next one. So after doing this, let's go ahead with the next question that we have. Question number 10. 3 blocks are connected by a string as shown in figure below and are pulled by a force capital F is equals to 120 Newton. If M1 equals to 5 kg, M2 equals to 10 kg and M3 equals to 15 kg, masses of each 5, 10, 15 is given. Calculate the tension T and acceleration of the blocks. See, if you cannot judge the diagram, I will draw the diagram for you all. It's given M1, then we have M2, then we have M3. Now they are pulled by a force of 120 Newton. So I am showing you here F 120 Newton. They will be moving together with common acceleration A. They are moving on a frictionless surface, the smooth surface, and pulled by a force F 120 Newton. So first of all, we need to find out the common acceleration. That's quite easy. Acceleration will be net force upon total mass 120 divided by M15 plus 15 plus 20, that will be 40. You can see M1 is 5 and 10 and 15. So 5 and 10, that is 15 plus 15, that will be 30. So I'm writing 5 plus 10 plus 15. So 120 divided by 15 plus 15, that is 30. So that is equal to 4 meter per square second. Next thing, we need to also evaluate the tension T in this string. So the tension T, let me mark here as T. This mass is moving with some acceleration that is 4 meter per square second. So if I draw the diagram of M1, that is actually equal to 5 kg, tension T is pulling it here, the acceleration A we have evaluated, that is 4. So T will be equal to M1 into A, so 5 into 4, that turns out to be 20 Newton. Tension is 20 Newton, acceleration is 4. Let's check the answer. 20 Newton is the tension, acceleration is 4 meter per square second. This is the answer for B and C are the right answer for this question. So we have seen that in today's pattern, we have seen single choice, more than one choice, and integer type of question. Even matrix max is also asked. Even assertion reason is also asked in JEE Advanced questions. Now, after all this such kind of practice, I want you all that you also practice some more questions on your own. That will be very much beneficial for your preparation. And with all this practice, you will find that you can reach up to a good state. Next thing, after this session, we'll be discussing more questions, and I'll be meeting you all in the next lecture. Till the time, thank you everyone. Wish you all the very best.